At this point, we can grab the handy-dandy cancellation pen, cancel those factors of cosine, and we get a result of 1 divided by the sine. And we're going to re-express that so that it's not in fraction form. 1 divided by sine, or the reciprocal to the sine function, is the cosecant function. So cosecant of theta is the final result in simplest form. In C, we have sine squared of theta divided by the cosine squared of theta, and that is the same thing as sine of theta divided by the cosine of theta, all squared. Since it's already in terms of sine and cosine, we can transition this. Sine divided by cosine is the same thing as tangent. Now we're not going to leave it looking like this. This is not the conventional way to write the square of a trig function, so we're going to rewrite it as the tangent squared of theta, and that will be our simplest form. In D, we have 3 trig functions multiplied together, so I'm going to rewrite each using sines and cosines. So secant of theta is 1 divided by the cosine of theta. Cosecant of theta is 1 divided by the sine of theta. And cotangent of theta is cosine of theta divided by the sine of theta. I'm going to grab my handy-dandy cancellation pen, cancel those factors of cosine, and then we'll just get 1 over the sine squared of theta when we multiply, and 1 over sine is cosecant, so this is cosecant squared of theta. All right, pause the video while you try this next one. As a strategy here, I would probably use division, rewrite using the old school division symbol. Hopefully you got a result of sine cubed of theta. So when I rewrote it as a division, I just re-expressed that as multiplication times the reciprocal, and I know the reciprocal to cosecant is sine, which made it pretty easy to simplify. All right, let's pause the video here while you try this last one, F, on your own. Hopefully here you got a result of sine squared of theta. In addition to the 3 main trig functions, sine, cosine, and tangent, there are 3 additional ones, and their names are the secant function, S-E-C-A-N-T, the cosecant function, and the cotangent function. They're reciprocals of the 3 familiar trig functions. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. When you're memorizing these pairs, it's helpful to notice that each pair has only one cofunction. That is a function that starts with the prefix co. So the reciprocal of cosecant is sine, the reciprocal of secant is cosine, and the reciprocal of tangent is cotangent. All right, in example 1, we're going to draw an angle in standard position and then use it to find the indicated trig ratio. So this should be something that's fairly familiar to you. So in example 1a, we have cosine of theta is 3/5. For an angle theta that's between 0 and 90, that means it's going to terminate in quadrant 1. And so I'm going to draw a reference triangle in quadrant 1. And cosine is 3/5, so that's adjacent over hypotenuse. We remember our Pythagorean triples, 3, 4, 5. And so the opposite side must be 4. And then from there, we're asked to find the ratio for cosecant, which is the reciprocal of sine. So I'm going to start by finding the sine ratio first. Sine of theta must be opposite over hypotenuse. And that means that cosecant of theta must be the reciprocal of that number. Let's take a look at B. For this, we have an angle theta that's between 90 and 180 degrees. So in standard position, that's going to be terminating in quadrant 2. So I'll draw a reference triangle in quadrant 2. Here's our angle theta, and here's the reference angle in the triangle. The sine is opposite over hypotenuse, 5 over 13. Our missing side is 12 for the 5, 12, 13 right triangle, but since that side is adjacent in the second quadrant and it's pointing left, that's going to give us a side of -12. We're asked to find the cotangent ratio. Cotangent is the reciprocal to tangent, so I'm going to start by finding the tangent. The tangent is 5 over -12, opposite over adjacent. So we can just flip that or find the reciprocal to find the value of cotangent. So cotangent of theta is equal to -12/5. In C, we have an angle that is between 180 and 270 degrees, which means it terminates in quadrant 3. And so I'll draw a reference triangle in quadrant 3. And our angle theta and the reference angle of the triangle. Tangent is 3 over 2, that's opposite over adjacent, but in quadrant 3, both opposite and adjacent must be negative, which will still give us a positive tangent ratio. And we're asked for the cosecant ratio. And the cosecant ratio is the reciprocal of sine. So we're going to start by finding the sine ratio, and then we're going to flip it over to find the cosecant ratio. Before we do that, we need to find the missing side length, or the hypotenuse. 3 squared is 9, 2 squared is 4, so our hypotenuse is the square root of 13. And the sine ratio is opposite over hypotenuse. I'm not going to bother rationalizing that because for cosecant, I'm going to flip that over, and so we'll have our radical in the numerator, which is allowed, and the denominator is a rational number, and so we don't have to do any rationalizing there. In D, even though we have some information given about the angle, you'll notice that it's not actually necessary because the given ratio is the cosine ratio, and the requested ratio is the secant ratio. Secant is the reciprocal to cosine, so secant is just the reciprocal of the given cosine ratio. And the only thing that we need to do with that now is rationalize that. So multiply by square root of 3 over square root of 3, and we get 2 times the square root of 3 over 3 for the end ratio. So the sketching is can be a tool, but it's not necessary for this particular one. All right, please pause the video while you do this next. Try this. All right, hopefully you got a result of cotangent of theta is equal to 15/8. This involved remembering the 8, 15, 17 Pythagorean triple. All right, moving on, we're now going to evaluate trig functions for some of our common angles that we see. So for instance, 30 degrees. For this, I'll sketch a triangle, reference triangle in standard position for 30 degrees. The opposite side will be 1, adjacent square root of 3, and 2 for our 30, 60, 90 triangle hypotenuse. We're asked for the cosecant, so we're going to find the reciprocal function first. So sine of theta is 1 over 2, opposite over hypotenuse, and that means that the cosecant theta value is the reciprocal of the sine. Reciprocal of 1/2 is 2. Now we're going to find the secant ratio for 90 degrees. And since 90 degrees is a quadrantal angle, we're going to use our strategy of finding the endpoint of the terminal side, which will be the point 0, 1. 0 is our A value, which is the adjacent side, and 1 is the B value, which is the opposite side, and C, our hypotenuse, is 1. So the secant is the reciprocal of cosine. So cosine is adjacent over hypotenuse, and adjacent over hypotenuse is 0 divided by 1, which is 0. And if we flip that to find the secant value, we find the reciprocal of 0, which is 1 over 0, and 1 divided by 0 is undefined, so secant of 90 degrees is undefined. Pardon me, I've put theta here, and what I meant to put was 90 degrees, so secant of 90 degrees is undefined. Since 120 is a second quadrant angle, we can draw a reference triangle in quadrant 2, and the supplement is the reference angle, that's 60. Our opposite side is the square root of 3, adjacent is -1, and hypotenuse is 2. So secant is the reciprocal of cosine. Cosine of 120 degrees is adjacent over hypotenuse. So the secant of 120 degrees is just the reciprocal of that value, which is -2. To find the cosecant of 270 degrees, we need to rotate 270 degrees. That's a quadrantal angle, so we can attack that with the strategy of an endpoint of the terminal side. And the endpoint of the terminal side is 0, -1. Remember that A is our adjacent side, and B is the opposite side, and C is the hypotenuse, which will be 1. Cosecant is the reciprocal to sine, so sine of 270 is opposite over hypotenuse, that's -1/1, which is -1. The cosecant of 270 degrees is the reciprocal of -1, which is -1. For E, we're finding the secant of 210 degrees. And so that's going to be a third quadrant angle with a reference of 30 degrees. Opposite side will be -1, adjacent -square root of 3, and hypotenuse 2. Secant is the reciprocal to cosine, so cosine of 210 is adjacent over hypotenuse. And secant of 210 is the reciprocal to that number, which is -2 over the square root of 3. Now we just have to do one more thing, and that is to rationalize the denominator of that result, so -2 times the square root of 3 over 3. For cotangent of 330 degrees, we can draw an angle that terminates in quadrant 3. That will give us a reference triangle with a 30-degree reference angle. And that gives us an opposite side, -1, adjacent positive square root of 3, and hypotenuse 2. And cotangent is the reciprocal to tangent. So tangent of 330 degrees is the opposite side over the adjacent side. We're going to flip that over to find the cotangent of 330. And the cotangent is the reciprocal of that, which is -square root of 3. Pause the video while you try the next one on your own. Hopefully you got a result of -square root of 2. All right, we're going to shift gears now, and we are going to develop one of the quotient identities. So we're going to use SOHCAHTOA to do that. It was typically not the way that we prove things, but this is essentially a proof. You'll know that from the phrasing, show this is true. It's not a typical proof in the way that you did two-column proofs in geometry. This one will be a little bit different. So I'm trying to prove that sine of theta divided by cosine of theta is equal to the tangent of theta. So I'm going to start with sine of theta divided by the cosine of theta is equal to the sine of theta divided by the cosine of theta. I hope that's an intuitively obvious starting point, right? It's true because anything is equal to itself. In geometry, you justified that step with the reflexive property. What I'm going to do is I'm going to leave the left side alone, sine of theta divided by cosine of theta. I'm going to try to turn the right side into tangent of theta to prove what we were asked to prove. So I'm going to use SOHCAHTOA, and that means that sine can be replaced with opposite divided by hypotenuse. Cosine can be replaced with adjacent divided by hypotenuse. Now we have a fraction over a fraction, which is a fraction divided by a fraction. So I'm just going to rewrite opposite over hypotenuse divided by adjacent over hypotenuse. So sine of theta over cosine of theta is equal to opposite over hypotenuse times the reciprocal hypotenuse over adjacent. Now we can grab our cancellation pen and cancel those hypotenuses. And now sine of theta divided by cosine of theta is equal to opposite over adjacent. And we know that opposite over adjacent is the ratio that is equal to tangent of the angle, so tangent of theta. And so now we've arrived at the equation that we were trying to prove. So I'm going to write the letters QED, which is Latin, stands for quod erat demonstratum. It has now been demonstrated. That's a stylistic thing. You can include that at the end of your proofs if you wish. This brings us to the quotient identities. Tangent of theta is equal to the sine of theta divided by the cosine of theta we've just proved. And I think an easy jump from there is, since cotangent is the reciprocal to tangent, then cotangent must be the reciprocal cosine over sine. Now we're going to use all 5 of these reciprocal and quotient identities to simplify expressions. In example 3, we have the expression cosine of theta times cosecant of theta. In order to simplify, generally speaking, I'm going to try to turn all of my functions in terms of cosine and sine, which are the building blocks for all trig functions. So cosine of theta is cosine of theta, and I can put it over 1 to make it a fraction. Cosecant is the reciprocal to sine, so cosecant is 1 divided by sine. And then if I multiply, I get cosine over sine, and that's one of our quotient identities that we just talked about. Cosine over sine is equal to the cotangent of theta. So that's probably about as simple as I can get that to look. In B, when I'm simplifying something that's in fraction form, a strategy that may be helpful is to rewrite as a division. Secant of theta divided by tangent of theta, or just to write the division in a different way. Secant of theta is 1 divided by the cosine of theta, since secant is the reciprocal to cosine, and then that's divided by tangent of theta, which is sine theta over cosine theta. When I divide fractions, I change to multiplication and the reciprocal of the divisor.